In this video, I'll explain the functional area charge. The requirement is to charge electric vehicles absolutely safely and as quickly or gently as possible, according to the technical possibilities and requirements. The required current is fed into the charging station via the functional area power reliability, while the functional area control and monitor regulates the charging process. The AC and DC concepts are differentiated in the charging process itself. AC charging stations are primarily located in public parking lots or in private areas. The simpler AC concept offers slow to medium speed charging with currents in a range of 6 to 32 amps. The power ranges from 3.7, 11 and 22 kilowatts. One unique feature of AC charging is the onboard charger installed in the vehicle. It converts the incoming AC current into DC current with which the battery is charged. The fact that this conversion takes place in the vehicle and therefore not in the charging station is one of the reasons why AC charging stations are generally less expensive than DC charging stations, making them more attractive for some applications. Please note that home chargers over 11 kW must be registered in some countries, for example in Germany. The background here is to prevent too many private charging points from overloading the power grid. Thus, regional requirements of state authorities or electricity providers may have to be observed. The AC power contactor makes contact between the grid and vehicle once the controller releases the charging process. These contactors are available on the market at low prices. In general, an AC charging cable can be mounted permanently on the charging station. In this case, the user does not need to have a mobile charging cable. The available cable can be connected quickly and also cannot be stolen. Because the cable is permanently attached, the charging station is somewhat more expensive for the operator. Although the charging cable and connector are drive-over resistant, they must be replaced if they are damaged. The AC charging cables, CHARX Connect, are available in different power classes and market standards. Various charging standards originating in North America, Europe and China have become established throughout the world. Every standard has its own mating phase. In the light gray countries, as of November 2021, no charging standards has yet been declared to be the official standard. Please obtain information on current tendencies and decisions in your region. This image shows the mating phases of the charging connectors and inlets on the vehicle side. Type 1. Introduced in the USA and mainly for North America. Type 2, originating from Europe, and GBT for China. At the types 1 and 2, unused contacts are visible in the bottom area of the vehicle inlets. We'll come to this later on. As an alternative to the permanently connected cable, the charging station can also be equipped with a charging socket. The advantage here is that the infrastructure is less expensive and less susceptible to damage, for example caused by vandalism. Users bring their own mobile charging cables to connect the charging station to the vehicle. Such a mobile cable can be used both on a home charger and a public charging station. The charging sockets CHARX Connect are also available in a wide range of power classes as well as with different mating phases and functions. For example, the included locking actuator can be controlled with 3 or 4 positions to fulfill the different market standards. If necessary, the socket can also be equipped with temperature sensors and LED display. When which functions are used is decided by the user's needs in terms of safety, convenience and budget. To connect the charging cable, the last component needed is the appropriate charging inlet, which is integrated in the vehicle. Of course, the inlets are installed by the vehicle manufacturer and are designed to match the charging concept for the vehicle as well as the charging power that can be fed in. The vehicle inlets CHARX Connect are available in the variants mentioned before, for AC charging only, for DC charging only, or as a combined CCS inlet for AC and DC charging. CCS stands for Combined Charging System. Phoenix Contact played a key role in the development of this system. Especially when traveling, fast charging is important in order to achieve the required ranges. DC charging is required at power levels above 22 kilowatts. In some cases, high power charging with up to 350 kilowatts is already established. The availability of even higher powers and therefore shorter charging times is already emerging. The infrastructure required for this purpose is more complex and cost-intensive than that for AC charging and is generally used for commercial applications. The common factor with AC charging is the power contactor for switching the charging currents. However, in DC charging the power levels are significantly higher. DC power contactors are available on the market and are specially designed to safely interrupt the charging process even in case of an error or underload. A fuse must be installed upstream of the power contactor to protect the charging process, additionally against overcurrents. These fuses are available on the market. The unique feature and the cost driver for DC charging is the DC power electronics. Already inside the charging station, it converts the alternating current from the local grid into direct current, which is required by the vehicle battery. In AC charging, this conversion is integrated in the vehicle as mentioned before, but such onboard technology for the higher power levels in DC charging would be too costly and uneconomical. The power electronics Charx Power is available in the classes 20, 30 and 87.5 kilowatts. In addition to classic AC grid current, DC currents can also be converted. The required charging powers of up to 350 kW can be achieved by interconnecting several power modules, so systems can also be expanded later. Thanks to the 19-inch standard, the modules can be mounted both directly in the charging station and in separate control cabinet. The DC charging cable to connect the vehicles is permanently attached to the charging station. On the one hand, this is a safety aspect and it's therefore required by applicable standards. In addition, the cable and connector can heat up significantly at high power levels depending on the conductor cross-section, climate and UV rays. Therefore, liquid cooling is required at least above 250 and 300 kW in order to avoid overheating. The liquid-cooled HPC charging cables from Phoenix Contact are able to deliver up to 500 kW continuously and offer a secure reserve in case of lower power levels. All DC charging cables Charx Connect are, of course, available in the commonly used charging standards with the appropriate mating phases. In CCS Type 1 and 2, the geometry of the upper mating area is identical for AC and DC, so that both AC and DC connectors fit into the same charging inlet. The DC connectors additionally have the lower area, which contains the DC contacts that are designed for the higher power levels. This means that automotive manufacturers only need to install one inlet in the vehicle. This saves components, space and money. At the same time, this allows drivers to enjoy flexible AC and DC charging through this single inlet. The Chinese GPT standard does not follow this concept. Under this standard, different inlets and connectors are required for AC and DC charging. As noted, cooling is required above 250 to 300 kilowatts. This is the only way to ensure the continuous high power transmission within a safe temperature range. The cooling unit pumps environmentally friendly coolant through the HPC cable and connector. The temperature measurement is done by multiple sensors, on the contacts, in the cable, and on the microchip PCB in the connector. A further sensor checks the coolant circuit for leaks. All measured data is reported directly to the charging controller in order to control the cooling intensity and to initiate a safe shutdown of the charging process if needed. Overall, the broad and scalable Charx portfolio offers numerous combinations to safely implement all variants of AC and DC charging. This means the right solution can be created for any application, from private home chargers to fast charging parks.